Okay, so we're going to begin chapter 4. We're going to talk about triangles in chapter 4, starting with section 4.1, which is applying the triangle sum properties. First of all, we have already talked about polygons, and a triangle is a polygon with 3 sides. We name it with the little triangle symbol and the 3 letters that make up the 3 vertices of the triangle. They can be mixed up in any order to name the triangle. Now, this picture right here is taken from the textbook on page 217. And there's 2 ways we can classify triangles. One way is by looking at the sides, and one way is by looking at its angles. So a scalene triangle has 3 completely different side lengths. All sides are different. An isosceles triangle is when 2 of the sides are congruent. And an equilateral triangle is when all 3 sides are congruent to each other. Then we have 4 ways we can classify triangles using the angles. An acute triangle has all 3 acute angles. Remember that acute angles means they are less than 90 degrees. A right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. And a triangle that is equiangular means all 3 angles are congruent. And since they make up the interior of a triangle, then they all have to equal exactly 60 degrees for this to happen. So again, classifying triangles by their angles, you can have an acute triangle, right triangle, obtuse triangle, or an equiangular. All right, so next we're going to use that information to help us classify some triangles. A triangle that has lengths of 5 centimeters, 7 centimeters, and 5 centimeters. Well, this is talking about side lengths, so we're going to use one of our side classifications. Notice that these 2 are the same measure, the 2 5 centimeters, so that would make this an isosceles triangle. Okay, so the next one gives 3 angle measures, 60 degrees, 60 degrees, and 60 degrees. Notice that they're all the same. So this would be one that is equiangular. So since we're talking about angle measures, it's equiangular. All right, moving on down. All right, so now we're going to talk about the angles formed with a triangle. And I've kind of color-coded them here on my notes. The interior angles of a triangle are the angles on the inside of a triangle. So I've kind of color-coded those on my little triangle. The angles that are formed on the inside of a triangle are called the interior angles. If you extend the lines of your triangles, the little angles that are formed on the outsides of the triangles are called exterior angles. So if you extend the lines, the angles that are formed on the outside of the triangle are called exterior angles. All right, so on our handout for chapter 4, on our theorem and properties handout, there's 2 we're going to go over right now. One of them is called the triangle sum theorem, and it's something that's going to help us quite a bit when we're talking about triangles. And it tells us that the measures of the interior angles of a triangle have a sum of 180 degrees. So the sum of the measures of the interior angles of any triangle is 180 degrees. So we just add them all up. They should total 180 degrees. Then we have something called an exterior angles theorem. The exterior angles of a triangle, remember, are formed by extending the lines of a triangle. So if we know 2 interior angles then that are not touching the exterior angle, then we can add those together and get the measure of the exterior. So notice that angle 1 is adjacent to angle C right here. Angle 1 is an exterior angle of this triangle, but angle 1 is not adjacent to angle A and angle B. So if I know the interior angle measures of angle B and angle A, then I can add those together, and that will tell us the sum of angle 1. So we're going to see some examples of using the exterior angles theorem. So it says find the measure of angle JKM. Well, if you look at the figure, JKM is this exterior angle right here. And I can't tell you what that is just yet because I don't know what X is. So my first job is to find X. And the way I can do that is by setting up an equation that says this angle plus this angle equals the exterior angle 2x minus 5. So angle L and angle J are non-adjacent to the exterior angle, so I can add those together and set that equal to the exterior angle. So I'm going to say 70 plus x equals the exterior angle, which is 2x minus 5 degrees. I'm going to solve that for x. So subtract x on both sides. 70 equals x minus 5. I'm going to add 5 on each side. 70 plus 5 is 75 degrees. Well, I'm not finished because I want to find the measure of that exterior angle. So to find the measure of angle JKM, I'm going to say 2 times 75 degrees minus 5 degrees. I should plug that in for x now that I know that x is 75 degrees. So that's 150 minus 5. So the measure of angle JKM is 145 degrees. All right, let's do another one. This time it wants me to find the measure of angle DEF. Angle DEF is the exterior angle of that triangle. So I can add the two interior angles that are non-adjacent to that exterior angle. So I can add the measure of angle F and angle G and set that equal to 3x plus 6. So I can say 80 plus x equals 3x plus 6. Solve it for x. I'm subtracting x from each side. 80 equals 2x plus 6. Subtract 6 everywhere. 80 minus 6 is 74. And I divide by 2, and I get 37 degrees for x. But it wanted us to find the measure of angle DEF, so I plug that in. So the measure of angle DEF is 3 times 6. 3 times 37 is 111. Plus 6 degrees. So the measure of angle DEF is 117 degrees. All right, one more. This one is a little bit different because this time we want to actually find the interior angle of angle 1. So before we can do that, I have to find x. So I'm going to use that exterior angles theorem again. I'm going to add the two interior angles that are non-adjacent to that exterior angle 5x minus 10. So I can say 40 plus 3x equals 5x minus 10. Getting my x's together. So 40 equals 2x minus 10. Add 10. 50 equals 2x. Divide by 2. 25 equals x. Now there's a couple of different ways that we can get the measure of angle 1 now. I can plug 25 in for x right here and say 180 minus 40 plus 3 times 25. So that's going to be 75. So 180 minus 40 plus 75. 40 plus 75 is 115. And so the measure of angle 1 would be 65 degrees. Or I could plug that 25 in for right here, and that's 125 minus 10, so this is 115 degrees. And it makes a linear pair with angle 1, and again I can subtract 180 minus 115 to get the measure of angle 1. So there's two different ways after you find x that you can plug in and find the measure of angle 1, which is an interior angle. All right, next we talked about a corollary. A corollary to a theorem is a statement that can be proved easily using the theorem itself. So the triangle sum theorem, if you recall, is that the sum of the interior angles of a triangle equal 180 degrees. So one corollary to that theorem is the acute angles of a right triangle are complementary. So remember, complementary means they add to make a 90-degree angle, or 90 degrees. So let's just say that's true. we have a right triangle here. There's my 90-degree angle. This one and this one are my acute ones. So obviously, if all three angles have to add to make 180, and this one's already 90, then that means this one plus this one will have to add to make 90 as well. So that's where that corollary comes from, based off of the triangle sum theorem. Okay, so it says a staircase forms a right triangle. So I'm going to draw the base of the stairs being a right triangle. So you can have steps going up it. Okay, this is a right triangle. It says one of the acute angles in the triangle is twice the measure of the other. Find the measures of each acute angle. So one is twice the measure of the other means 2 times the measure. So if this one is x, twice x would mean 2 times x. All right, so using that corollary we just talked about, since I have a right triangle here, then the acute angles have to equal 90 altogether. So if I add 2x plus x, I can set that equal to 90 and solve for x. So those are like terms. 2x plus 1x is 3x equals 90. Divide by 3, and x equals 30. So that's one acute angle is 30 degrees. Again, twice means 2 times it. So 2 times 30 would be 60 degrees. So my two angle measures would be 30 degrees and 60 degrees. And again, double check, they do add to make 90 degrees. All right. This is our last example for the day. We're going to use that same corollary to the triangle sum theorem. Find the measures of the acute angles. So if you look at the picture, that is a right triangle. It's got a 90-degree angle. So that means these two acute angles have to equal 90 together. 2x plus x minus 6 equals 90 degrees. Like term, 2x plus 1x is 3x minus 6 equals 90 degrees. Add 6. 3x equals 96 degrees. Divide by 3. And 96 divided by 3 is 32 degrees. So to find the two acute, I'll just plug those in for x. One of them is 2x. So 2 times 32 is 64 degrees. Now you could say 90 minus 64 to get this bottom one, or you could go ahead and say 32 minus 6, because x is 32, and that is 26 degrees. So those are my two acute angles for that triangle. Again, once you get one, you have options of different ways that you can get the other one. And that is all for section 4.1. Have a great day.